One of the things that was brought up, we discussed, was aging workforce. And aging workforce means that people retire. And when people retire, then there will be lack of people who have the expertise in obtained over time to do the tasks. And that is a quite important thing. Also, before they retire, they will maybe also not be in the same physical situation as they were before, and they will need younger people to do some of the heavy lifting, etc. If it's that type of jobs. And these are the a big challenge that a lot of companies are experiencing now, that they simply cannot get, for example, skilled blue-collar workers who are capable of maintaining the machines, repair, maintenance, changeover situations, and their Internet of Skills can be the call it very crucial thing to have. An example could be on board vessels, where over time crews have reduced in size, meaning that those technicians who are working in the engine room have to be able to fulfill a lot of different tasks. These tasks might actually create safety hazards, and where Internet of Skills can secure that they avoid doing this. Also, if it's a pump that hardly never breaks and therefore no one has done it in a long time, then having a procedure, standard operating procedure that will help the person disassembly and reassembly the pump while at sea would be very, very crucial. You don't have to fly in a technician on a helicopter and fly out again afterwards, and all the travel. So what we are talking about here is that there's value for the planet in reduced travel CO2 emission. So the type of skills that we are talking about here, sorry for jumping a little bit, could be quite non-linear processes where things become more an art rather than a science on how to set parameters and check based on, okay, when the engine sounds like this, that type of behavior, that means that I have to adjust a little bit extra, or whatever it could be. It could also be used for remote support, where you need to have maybe combine video communication with augmented activity level capabilities, annotations that will stay on screen where they were given, etc. It could be either by using AR, smart glass and smart glasses, digital twin into digital twin info providing directly to the remote technician, who can both see what's happening and then get feedback from the machines. Yeah, a lot of options available. We discussed that TDC had an example of the aging workforce, that old machines that has to be decommissioned, equipment that has to be decommissioned, but nobody knows how to do it unless that you keep people who actually already are past retirement age in order to do that job. So if you have that ability to emulate an expert and give the advices, that would be a good thing. I don't know, did I cover most of it?
Yes, pretty much all of it.
Yeah, well done.
Thank you.
Yeah, good slide. Good work, team.
Thank you.
I'll jump to another team. What about team 7? Do you feel up for it?
Yeah, I could actually. I got a little comment in there. Yeah.
That's the one, right?
Notes. Sorry, it's a little messy, but I could explain what we discussed about. So yeah, we spoke about. I'm actually from STU, Southern Denmark University. My name is Maya. We spoke about 2 different cases: one remote training and one service from distance. So yeah, of course, these interactive skills will help a lot regarding to solving these challenges regarding distance, time, and accessibility. And what we felt is important was having a human in the loop, because in fully automated systems is a little difficult. You cannot imagine, for instance, we were thinking about different ways that we could transfer skills. One could be from human to human, human to intelligent system, and system to system. And for instance, if we are going to apply this interactive skills into a fully automated system wherein there is no human, and there, for example, is a safety critical system, that could be an issue. So yeah, this human in the loop was something that we really discussed about. And regarding what will be what sort of challenges will be solved regarding accessibility. For instance, my colleague was working in this windmills and wind farms, and how we are going to control those, because accessibility to those are really difficult. And yeah, what sort of skills could be transformed? It depends on, again, we are speaking about human to human or system to system, so it changes. And yeah, one important aspect here is in terms of things. So in the end, we spoke also regarding that if we could create a sort of conceptual model for interactive skills, because sometimes we don't know what's interactive skills. Why controlling remote controlling of systems could be interactive skills, and so what sort of skills are gonna be transferred through internet and that. So because recently we had another concept in terms of behaviors, and we tried to I put actually a comment in there. We tried to create a sort of conceptual model for that, with interviews with experts and literature review and sort of that. And yeah, that would be much more clear if you have a better understanding of what's considered intensive skill and what's not considered.
Yes, thank you, Maya. That makes sense. It was an interesting question you asked about, the human to human and system to system. Is it actually the same, or should we call it differently? Anybody else? Another team? One more? We have time for one more. 6, Anas, is that what you said?
Team 6, maybe? Nobody's ever raising the hand.
Exactly. So 6, team 6.
Yes. Hi, this is Prashant from L&T. So the solution that we basically considered for this particular slide was primarily it's a remote monitoring of industrial equipments in a large steel plant. So it's basically a huge space with multiple substations in it, which supplies all the power and required gas to the manufacturing plant. And the challenge typically is, again, this is a large area. There is a possibility of flooding whenever there is a rain, and somebody may not notice, and this will lead to the downtime of the plant, right? That's one of the biggest challenge. And considering the large steel plant, a small downtime is going to have a huge impact. So what today we have done is we have enabled basic remote monitoring by getting the sensors for some of the critical equipments. So again, typically these equipments are not connected to PLC and SCADA kind of a systems. So we kind of identified some industry grade sensors enabled to all this gas flow and the electricity and etc. to remotely get to know to basically get an awareness of this substation. and also to alert the plant supervisor and operator in case of any potential failures so that they can take actions on it. So that's the high level context. And then obviously challenge here is a large plant. Somebody has to physically travel in this plant to find out what is the condition of it. And again, it is spread across, these substations are spread across the plant in different areas. That's another challenge. Obviously, transportation is one of the biggest challenge to reach each of this site. And typically the plant supervisor will assist these operators or the electricians who typically go there to kind of help them in fixing the current situation based on the condition. And that again, today we only have a remote monitoring solution where supervisor basically gives some basic inputs. What we were thinking of is obviously having a camera or voice-based assistant where a plant supervisor who has a knowledge can assist the operator. That would again be of a great help. And another thing is by capturing the real-time status of all this condition, you can reduce the field visits. That's another thought process that we had. So from value related to the people standpoint, since it is a substation, there is a huge risk in terms of getting exposed to the hazards. So obviously having a remote condition monitoring will reduce this, and its safety, it ensures the safety of those employees. And also you can reduce the frequent visits to that particular station, right? So that's another aspect from the people standpoint. And obviously this will also reduce the travel, the number of travel that you're reducing is going to reduce the carbon. So that is from the planet standpoint. Very important aspect why we started this solution is unplanned downtime, which obviously can get addressed through the remote monitoring and certain alerts that we will enable. And by enabling the remote access, like through AR, VR, or some kind of a voice assistance, you can reduce the number of specialists that are there in the plant as well. The plant supervisors who has the knowledge on this. So that's our thought process. And thanks to Michael who was helping me in this.
Thank you very much. Well, one thing I can say, and this is in no way critique, but also one thing that is often overlooked is this accessibility to sites. So when you talk about a steel plant, for instance, then it's very often that it's very hot, and sometimes it's hard to access due to safety restrictions. As I mentioned in my first example as well in the bridge monitoring, all of the safety courses and training and protective gear that you need is something of an accessibility challenge. Also in many cases where we see IoT monitoring being performed and where you can then transfer the skill to somebody who has this equipment and training, etc. So I think that's an important point to include as well. Thank you all for all of these good inputs. It was very interesting to hear your take on the Internet of Skills, and certainly something that we can move forward with. We have, unfortunately, an apology from Toktam, from Michele College, who's not able to be here, but the next speaker we have is Mischa Dohler, which Mischa?
Yeah, so what I'll do is I will cover for Toktam.
Yes.
And what I thought I've seen right now the slides from Toktam. She just sent it over to me, so I'll reverse maybe our presentations if you don't mind, because she has very application-driven applications which are very fascinating. So I thought let's talk a little bit about the vision first. And for me, it was actually quite a fantastic exercise, to be honest, to be now part of these discussions, because the term has really come a very long way, which I'm extremely happy about. So let me just bring this up. I hope you can see that. So I'm Mischa Dohler. I'm now Chief Architect at Ericsson Inc. here in Silicon Valley. So I'm sitting in California, Santa Clara. You can see my palm trees, they are real. So this is not a fake background. The sun is just coming up. It's going to be very hot today. So
Mischa, your camera is off right now.
Okay.
But thank you for being on this early.
Yeah, let me just have a look. Do you see me now?
We can see you, or I can see you.
Then it's just me. Sorry.
Okay, all
You're
right.
avoiding the palm trees.
Yeah, I mean, I'm not that pretty for you to needing to see me, but anyway, so.
I was just about to say that you're looking good, so.
Yeah. All right, so, and I was, as professor at King's College in London for many, many years, where I was heading the Center for Telecom Research, which Toktam is heading now. So we usually make a good tandem team here. She sends her apologies. She doesn't feel very well today, so I'm just covering. I think it's no problem because I have overseen her doing her fantastic work, so I can cover that easily. But yeah, let's talk about this Internet of Skills. And it's come a really, really long way, I have to say. And initially, so this term was actually coined by myself in 2014 or 15, I can't remember. And back then, I kind of thought, what's going to be now the next internet? Because I realized we have been going internet by internet. We have been, designing the traditional internet where you use Ethernet cable, RJ45 to connect your computers. We built it, connected billions of computers, and that worked really, really well. Then we designed the mobile internet, right? We went from 2G, 3G, now 5G. We're talking about 6G already, right? So we did that pretty well, connected billions of phones. And after that, we started to design the Internet of Things, right? So the Things Internet. And actually, I was in France Telecom back then, and one of the 3 co-founders of the ETSI M2M standard, which has evolved to be really the pillar of support for all the industrial IoT developments, which you have been talking about right now. I went on then to found my own company, World Sensing, and I was the CTO and co-founder of World Sensing, and I was the one who gave companies like Cicleo their first commercial contract. Now, you don't know what Cicleo is, but Cicleo is the original founder of LoRa, right? So Cicleo was acquired by Semtech and then became LoRa. So I knew the founder really well from my France Telecom days. I was also the one who gave the very first contract to Sigfox. Ludovic is a good friend of mine. Now, sadly, they're doing financially not really well, so I think their assets are being sold. So these are companies you probably all know. I was there at the very early days, and having been part of that journey, I thought, it's going to be the next internet. And I thought, hey, it's skills, it's people, it's all about humans. So if I go to the next slide here, my vision was really to kind of transit from this world of Industry 4.0 to what I called Human 4.0, right? So I realized we're spending a good amount of time really kind of empowering machines. If you look at the top slide, top left corner, you see loads of machines, manufacturing hall. There's no human there, right? So we're designing technology essentially for machines, which is great, of course, to some extent, because you want to automate, you want to be more efficient, more effective, and all that's important. But I thought, let's not forget about people. Let's, the internets we have built is really about people. So I adopted Human 4.0, and the example you see here is, if somebody could teach me how to paint, I have no idea how to paint. So if somebody could remotely log in and, teach me the paint, really teach me that muscle memory, which you need to do that. Or if I could teach somebody to play the piano with that haptic glove. By the way, I found that haptic glove the other day when I was unpacking my stuff from London. So it's still there. This was a CNN filming we did in the King's College Chapel. And really my vision was to build an internet which would essentially enable that democratization of skills the very same way as the internet has democratized information, right? So, and that's really what we were after. And the internet took a long time to emerge. And, I didn't have time for that. So I really paid very close attention what really made the internet tick. And if you look at the top, the top line here, you see that maybe 40, 50 years ago, we were able to talk to each other via whatever media phones we called it back then. It was not only audio, but it was, some had video. But, the only way it would work is if you had what is kind of a human switch. It wasn't even packet switched or circuit switched. It was human switched, right? If people wanted to talk to each other, an operator had to put them together. And then, the engineering community, which we are all part of, did their magic over quite a prolonged period. They did a lot of things, but there are 3 things stand out really, and or 2 things stand out. One is that networking, a new networking protocol has been invented, IP, and IPv4 first, now IPv6, and as long as your machine, right? Whether that's a telephone, whether that's a mobile phone, whether that is a sensor and actuator, whether that's a supercomputer center, whatever. As long as your machine speaks IP, they can talk to each other, and that's really fascinating because we have completely flattened the internet with that, right? So that was a great development. And the other one, which I think is completely forgotten about and really undervalued, is that notion of codecs, right? So audio and video codecs, the MP3s and the MPEGs were invented. So today I can take a video on my iPhone and I can play it on my whatever computer I have, Dell computer, whatever, you know. So that is an ability which wasn't there around. We had actually a codec lock-in, so it would only work from Cisco to Cisco, Siemens to Siemens, and the ability to break out of these silos has really been powering the internet because we brought costs down, we increased the scale, and the rest, as they say, is history. So I looked at it and I thought, you know, how do we do this now with the Internet of Skills? And you know, King's College London had, for instance, you see here these robotic equipment. It's the Da Vinci Robot. I'll talk about this a bit later. So the Da Vinci Robot is there. It allows robotic surgery. You see the surgeon there looking inside a pulp, not at the patient, and remotely manipulating that operation. And we do that because it is much more efficient, effective, and it has loads of other benefits. And the patient is about 1 or 2 meters away, and the machine costs something like north of $1 million, or, you know, north of 1 million euros. Very expensive. So you can't possibly power an Internet of Skills where you transmit skills physically through the internet, right? So where I can reach through my camera, think of it, right? So I can reach you, I can shake your hands, I can give you a hug. You know, we can feel that haptic signal, that touch signal, and the kinesthetic muscle movement through the internet. With that type of machinery, that's too expensive. So I thought, you know, we need a few ingredients here. The first thing we needed tactile codecs, and I'll come to this in a moment. We need a lot of intelligence, and we need wireless networks, which are extremely low latency, okay, extremely low latency. And I'll explain that in a moment as well. And I thought, you know, to accelerate these 3 developments very aggressively, with the aim really of bringing down the cost, increasing the scale, and then hopefully, you know, enabling this new internet, which I hope would then power Industry 4.0, Human 4.0, etc. Right? And I learned just some really fascinating examples in my Team 4 about how could we, for instance, use that concept in an aging workforce. So that's really great, and the other examples you guys gave. Now we hit challenges very quickly. And, you know, the main challenge is around latency, and it's an important challenge. And the reason is because we have to operate within a 10 millisecond budget, and it's a 10 millisecond round trip budget. And the reason is because, you know, we as humans are geared for very low latency engagement windows. So the moment we get our optical signals into our eyes and it reaches our brain, that happens within 10 to 20 milliseconds, and over millions of years, we have started to build this emotional response to that very low latency. And you will confirm that when you speak over Teams or Zoom, you don't have that emotional bond compared to when you speak to people directly, right? So speaking to people directly is a very different thing, and the reason is because you get that 10 millisecond link. So that's number one. The second thing is we, of course, haptic signals, specific kinesthetic signals, right? So the ability to, you know, to hit and then get the reaction of the hit has to happen in a very, very short time. Okay, and I'll give you the example of a surgeon. Imagine a surgeon is operating across the world, and he or she cuts through the tissue and is receiving that feedback back saying, which tells the surgeon what tissue that is. If that feedback isn't coming back quick enough, then he or she may just cut through that tissue, and might be an artery and a vein. And, you know, I'm not a doctor, but I was told it's not a good thing to cut through these arteries, etc. Right? So you want to get that right and really get that latency right. So therefore, that feedback, that mechanical feedback, is actually super important. And another thing I learned, I'm not sure, I'll talk about this later, is that actually the tactile feedback, meaning the touch, is not latency sensitive at all. So you have a lot of time, right? So you may have heard the term tactile internet we've used in the past to describe this low latency network. In fact, it's a bit of a misleading terminology, because touch, you have a lot of time. It's a very time insensitive thing. And in fact, when you are moving, you don't feel touch at all anymore, which is why pickpockets are trying to get your wallets when you're walking, because your sense of touch is actually going down significantly. Anyway, it's on the sideway. The other reason we need 10 milliseconds is because machines need that stability. So robotic control loops, if you're an engineer, you know about the Lyapunov stability criteria. That is really required. So there are loads of different constraints here which tell us 10 milliseconds is a thing. But here's a challenge, If I want to, work from, let's say, from London to Los Angeles, or from Santa Clara, from Silicon Valley to London, you see these latencies here. So we have application delay. People forget about this. It takes about 60 to 100 milliseconds only to compress and decompress the Teams video signal, and my speech. So therefore, we have that latency here. Then the networks are very lousy. You've got a lot of congestions in the network, specifically to get in and out of the metropolitan areas. And then you have something which is extremely annoying, which is speed of light. It's nothing we can do about, right? So how do we get all these factors together such that, what technology can we offer to get it down to 10 milliseconds? Well, here we are, right? So on the green boxes, one way to deal with that is not to use any compression or very light compression, right? So, and we are working on this actually. So the ability to come up very low latency codecs, video and audio codecs, has become more and more important. Of course, the less you compress, the wider your bandwidth, and therefore the emergence of wide bandwidth networks such as 5G is hugely important. Then on the networking side, we've managed to get rid of a lot of the latencies because we introduced slicing. So the ability to reserve a highway for your packet is very important, and specifically end-to-end. So it doesn't make sense if I slice in with my Verizon network here in the US, and then I don't slice in the UK. So therefore, the end-to-end slicing ability is really important. But we can do it today. The technology is there. And the last one is all about AI, right? So we need to use a huge deal of AI because we need to essentially learn to predict the way we do things. And it turns out we are animals of repetition. So the way how I play the piano is the way how Mischa plays the piano. I do this again and again. The way how a surgeon does surgery is the way how he or she has been doing for decades. So therefore, AI is very powerful here to do these predictions of what's my next move. How am I going to move my fingers? And we don't need to predict minutes. We need to predict, tens of milliseconds just to get around that little speed of light, bummer we have there. And we're using it today. So gaming engines, I can tell you're all very avid Fortnite players. So if you're on Fortnite and you're using this multiplayer environment, there's a lot of prediction going on there, which gives you that feeling of immediacy, right? So we have these ingredients here, and we are working on this 24/7 to make that really reality. One of the challenges there is really around AI, and I don't want to spend too much time on this slide here. It's a bit tangential to our conversation today, but just wanted to let you know that not all AI is made equal. And one of the big things we struggle with is the ability of explainability, right? So how do you explain certain decisions of AI to be taken? So, and why is that important? Well, this is important because whilst in a Fortnite game, for AI to do predictions and maybe fail to do a prediction once in every 100 attempts is okay. It's all right, okay? So it's just okay. But in an industrial setting where you're trying to maybe remotely service a refinery, or where you're doing a remote operation on a human being, if you have a 1% outage, it's a real problem. So we need to know why certain decisions are being taken. So we need new AI. We need complete new families of AI. And in fact, that field was pioneered by my former colleagues at King's College in London and led now to this whole field of explainable and trusted AI. And I could probably speak another hour about this, but let me move on to the Haptic Codex. And that is something I recognized as a challenge very early on. And I told you why I recognized that, because I've seen that, I've seen a world where potentially we could end up with vendor lock-in. You don't want that. You don't want Siemens only to talk to Siemens, well, send sensing only talk to world sensing, ABB only to ABB. You really want the ability of haptic devices, whether these are gloves, exoskeletons, etc., to talk to each other, right? Speak a common language. So I therefore co-founded a standards group, which is the IEEE 1918 group, where we started to develop these Haptic Codex. And I have no expertise in haptics, so we called in Eckhard Steinbach, who's an absolute world leader in that field. And we started to develop that. And in King's, we contributed a lot. Toktam contributed a lot. Toktam students contributed a lot. So we have done a huge amount of work around these Haptic Codex, which you can see has split into two families. One is the tactile, so everything around touch. How do you feel touch? How do you reproduce touch? And in fact, that glove you have seen when CNN filmed me, and I think you had shown that on your opening slides as well. There's a guy sitting behind a keyboard and with a glove. That was me in my office, actually. And you know, this glove is able not only to take my movement, but also reproduce touch. So I can feel with that glove rain, I can feel touching objects in the middle of nowhere. So therefore we have the touch standards and we have the tactile, the kinesthetic standards, the way how you move your muscles and all that, right? So that's a really important field. And we then went on to build it and really started reaching out to loads of societal use cases, right? So our ambition was not only to build boxes and cables and write code, but show to society what it is useful for, which is why I really appreciate the discussion we have today, you know, the fact that you're on the call today to speak about that field, right? So, and we started to work a lot in London with doctors, and actually Toktam has a fascinating presentation around all the medical work we have done. So I'm going to present that in a moment. We've done a lot with artists work, right? So as an example here, I worked a lot with Massive Attack. So I'm not sure you know a band called Massive Attack. Rob De Naja, good friend of mine, he's a lead singer. And Rob is not only a great singer, he's also actually a painter, right? So he does a lot of spray cans and a lot of artwork. And we got two ABB robots, and we started to explore that notion of doing co-creation through AI, robotic devices, Internet of Skills, robot learning essentially from Rob, you know, how to paint and do that co-creation with him. And that's really, really interesting. And these were the very first baby steps in that world. But then I also had this really first experience. I'm not sure you can hear that. Can you hear the sound? Maybe not. No? Okay. Anyway, so let me just stop that video because I can hear it. And so this, you know, what happened here? So it was my very first kind of personal experience with 5G technology, and we really wanted to show this power of low latency, that power of immediacy, this power of transferring something which isn't just, you know, an email or, you know, a hugely delayed video link. And so I was here playing the piano, and I was in Berlin under the Brandenburger Tor, actually, a very iconic historic site. And the young lady you see beaming in there, her name is Noah. She, you know, she at that time she sang a lot at the Royal Opera House, and she is with Madonna on 2 songs on their latest album. And I'm showing off here, of course, because she's my older daughter, right? So Noah, my older daughter there, she's singing in London in the Guildhall, okay, in the Guildhall. The Guildhall, if you're a Londoner, you will know the Guildhall is a very iconic place. About 2,000 years old. You know, it was the UK's very first entertainment place, and the Romans brought it, right? The Romans knew how to party, and they brought that to the UK. So we thought, let's marry this very iconic historic place with modern technology. So Noah was beamed in real time through this holographic projection. And you know, the latency was so low that I really feel her beside me. It's very different to us talking on Zoom or talking on Skype and Teams or whatever. You know, that emotional bond you build by just being together over these huge distances. You know, he says, I really struggled not to cry actually that very same night when I was playing that song. You can Google that. You know, it's Maria Mena. It's Kiss, a song I was made for loving you, and I did a cover on another person's cover of that song. So that was my experience. I could really feel that power. First time I could firsthand. This was 2018. I could feel that power of low latency tech, and there's a fantastic teamwork, you know, with all my colleagues in King's, and we've worked with Ericsson to make that happen. And maybe as a side result, I was hired now into Ericsson as part of that project. But that was really exciting. So Ericsson actually picked up on this, and they started to write about this. This was before I joined the emergence of that Internet of Skills in 2018. A lot of work going on naturally within the company in this field to enable networks and the XR devices and everything. And we started to execute this, right? So, we have been doing the remote robotics. So it's happening, right? So with ABB, they were able to show that the future of work challenge can be addressed by remote rendering. So it's maybe a platform solution to that aging problem we talked about, the ability of somebody sitting somewhere in a control center and executing very highly skilled tasks through a low latency network, augmented by edge AI, and augmented by very advanced robotic equipment to do something which normally only a human being could do in the manufacturing hall, or AI cannot do yet, right? So I'm saying yet because I'm sitting here in California, I'm seeing things you start to get actually really worried. But anyway, so the other thing we did is, with a company called Biosurf, it's called the Iron Hand. In Volvo, they realized there's a lot of injuries happening in the manufacturing hall. So a lot of stuff, and it might be because pressure is very high to produce. Things get much more complicated and complex. And of course, the aging workforce, never thought about this, learned that today. I thought that's a really brilliant input. The aging workforce, you're just starting to get more and more injured. And having an exoskeleton with you, which is able to support you in physically very daunting tasks, is a great value proposition. But you can't have a very dumb exoskeleton. It needs to be an intelligent exoskeleton. It needs to take a lot of sensor data, starts to actuate in a very smart way, support the workload you're doing, be contextually aware, et cetera, et cetera. And for that, you need processing that's done on an edge cloud, and you need low latency to execute that essentially in real time. So this is really happening today, as part of the Ericsson, the Industry 4.0 engagement, and I'd be happy to expose you to more work we do there. So this is my last slide on that kind of intro visionary thing, and. Yeah, I'm happy to take a short pause and maybe for comments. I'm also happy to just move on to Toktam's fascinating slides and just talk you through, and we can have a discussion further on. So I'm taking a little bit of guidance here. What do you say? What do we do? Discuss now, or shall we do it after Toktam's slides?
Maybe it's a good idea if somebody has a question or a comment for Mischa now. Now we've talked about the vision of where we can be taken, but also what is actually feasible to do right now. Mm-hmm. I think one of the interesting challenges, Mischa, is the requirement specifications of the haptics, right? So today we are sort of, how much accuracy do I need in this sensor, or how much pressure do I need in this gauge? But trying to describe how much sense of touch do you need to be able to be taught to play the piano, for instance, right? So I think that's at least a challenge of when we talk about the vision, also us being professionals within that field.
Yeah. And the one thing I learned is I think it's a great question. So the one thing I learned over these years designing these networks and the codecs, is the distinction between this muscle movement, the kinesthetic signal, and the haptic signal. So we need to really distinguish that, because the requirements on sampling rate, the requirements of fidelity to take data and reproduce data, and the requirements on the network in terms of getting this across, physical distances is completely different between one or the other. Okay, completely different, has nothing to do with each other. So the haptic signals, the tactile signals, everything related to touch, are actually quite an easy thing to do. Okay, quite an easy thing to do. So it turns out that, whilst we are very susceptible when we touch, our skin, etc., we get touched, you don't need to sample that very frequently. So specifically, if you had a haptic glove on, you could take a few signals from somewhere, okay, and you could use essentially sampling theory to reproduce that signal at high fidelity on the other side. And the other side actually would, unless there's a physical object touching you, would really struggle to reproduce that to the point that no matter how hard you try, it's very hard to reproduce. And the reason is because we actually have, I believe, 6 tactile sensors in our skin. So it's not just one, there's 6. There's one responsible for feeling, pressure, one feeling vibration as you move your hand, as you move over the surface, one for temperature. So there's a lot of stuff going on in our skin, right? So to reproduce that meaningfully is quite a daunting task. But no matter, and I always maintain, the networks don't need to be particularly good. With today's networks, you can transmit a touch signal and you wouldn't notice the difference. And the other thing is that the moment we start moving, our susceptibility to touch actually goes really down. That's something I learned, right? The real challenge is the kinesthetic stuff, the muscle movement. This needs to be at high fidelity because you understand that if you do operations, surgical operations, if you do very fickle movements on maintaining an engine, you want to put some oil somewhere, right? You're doing something, which is really difficult. If it isn't difficult, AI or some robot could do it anyway locally. But we're talking about this human 4.0, the ability of somebody who's super skilled, who has been doing this for 40 years, they actually execute it remotely. So it needs to be super high precision in 3D, super high precision with time. So in 4D, it needs to be the right flow. All that needs to be transmitted in real time over a network with a very low latency. So these are the big challenges. There, the sampling specifically to build the codex is also not pretty straightforward because we have actually 6 degrees of freedom, right? So you need to transmit 6 degrees of freedom, but it's doable. So you can build, what I call these MP3s of tactile information to get the, of kinesthetic information to get that over. Yeah.
But then we need to talk about the challenges of encoding and decoding by the application and the latency related
Absolutely.
to that. Yeah,
Absolutely.
So I completely agree.
Absolutely. Yeah. I think we have one more question.
Yeah, but also just to comment, Mischa, that time is running a bit, so I think we will have to jump to Christian afterwards. Michele, you had a question, I think?
Yes, but it was a very quick point. I mean, really, really incredibly interesting, Mischa. But how far are we from the scalability of these type of solutions? So I guess that the development cost now is still very, very high. And what do we need to cut the development costs today when it comes to find a way to scale these solutions in industry? How far are we, and what do we need to do to cut that development costs?
Yeah, I think in industry we're almost there, I have to say, so we do have the networks now. So we do have that. That was a big ingredient. We need 3 things. We need the networks, we need the devices, and we need quite a bit of AI around this to make that happen. So the applications and all that, right? So we do have the networks today. We did our job in 5G, low latency, we can do that. The devices, we have been using exoskeletons and haptic devices in industry for a very long time, but they're very expensive, as you have rightly remarked. Now, my hope is that with the emergence of the metaverse out of Silicon Valley here and the massive investments going into this as we speak, will help a lot with these devices, because whilst currently people focus a lot on XR, so AR, VR, companies start to look at, hey, I want to have now a haptic experience as well, right? I want to transmit exoskeleton information as well. The moment these hyperscaler companies invest into this field, I think the costs will go down and it will trickle over into the industrial world as well. So we still need to wait this to happen. But I think why I find this workshop so fascinating today, and I'm very grateful that you have organized that, is that, of course, the third ingredient are the applications. Okay, it makes no sense to have devices and networks if you don't know what you use it for. So therefore, I invite you to be very creative, think about it, start building prototypes, and really get going. If you believe in that vision, Industry 4.0, Human 4.0. Yeah.
Thanks.
Great.
Fantastic.
All right, let me just bring up Toktam's presentation, because I'm very keen to present you the work she has been doing in King's College. Can you see that?
But Mischa, I think we should need to cut it to only like 5 minutes. I'm really sorry, but we're running out of time.
Yeah.
So maybe just a few essential points. Because I know you
so
could talk
Toktam talked a lot about, so we co-authored that paper together here. I'll leave you the slides with her. And she rightly identified the level where you can have teleoperations. So if you look at the delay tolerance versus the level of environment dynamics, Today we can do it where, you know, the dynamics, meaning things change very quickly in your environment versus your delay tolerant, you know, we're in this blue bottle, but we would like to get here. So this is really a dream scenario where we want to go. Toktam has done, together with Costa's, fascinating work in terms of how to really make this happen. And they used essentially humanly operated robotic things, and that they are side by side, but actually connected through a network which can emulate, you know, thousands of kilometers, and really looking at what's the real implication to human touch, the real implication to robotic kinesthetic movement. How synchronized does it need to be to pick up an object to do something on the other side? How easy or difficult is it to actually transmit these sensors? Right, so, and loads of applications we've heard about this, but King's Toktam really focused, you know, on education training. We looked at the performing arts, emergency services, mobile health, etc. And I want to particularly talk quickly about the last one. So we did a lot of work in the art space. I just showed you one before with Massive Attack. We worked with Jamie Cullum. We did three-way concerts, etc. We worked in the National Gallery. But this is a project which Toktam has done here with the emergency services. So one of the big skill sets you require is flying drones. You know, you need a license for that. I didn't know that. So imagine the ability now to use all skilled drone operators around the world to fly these drones in an emergency area where something has happened. For instance, a landslide, there's a fire, or you know, somebody has a problem somewhere, a heart attack in hiking in the mountains. So the ability to control that remotely is something which has really been pioneered by Toktam and the King's College crew, where essentially we use slicing, we connect it to the New York system, and you see here this happening in the courtyard of King's College. So this is a very, very interesting use case. Another one is really about the medical interventions, and this is a Vinci Robot here. The surgeon actually doesn't see the patient, so now they are controlling essentially these arms here. We had started working with Prakash Gupta. You see that person here. He is a pioneer in robotic surgery. So the ability to actually bring this across the planet is quite a proposition. And we built this Mobile World Congress demo in 2017 that had been augmented with this more general concept of ambulance on wheels, or hospital on wheels by Toktam in Mobile World Congress 2019. So you can do diagnosis, bring in a remote doctor from a hospital, help people with a stroke much earlier than the stroke actually happens. So there's a lot of really interesting work which King's and Toktam's team have done in terms of specifically medical delivery, you know, whether that is drones doing that or whether that is the ambulance on the move. Of course, again, we need the networks, we need the devices, and we need the applications, right? So, and the devices, you know, I'd skipped one slide if you just go quickly back. You know, the miniaturization of loads of devices is really coming very handy. So we see what we see on the tactile devices, the gloves becoming cheaper and all that. You know, all the medical equipment is also becoming cheaper. So you can actually fly it around. You can put it on an ambulance, and you can have then doctors remotely connect to it and operate. Okay, so I'm going to leave you with that. And please do reach out to Toktam and the King's team for any of these areas. Okay, so, and that's my last slide. That used to be the view from my office here in central London. Anyway, that's really it from my end.
Really incredible. And I think it also shows that there's a lot of, it takes a special mindset to sort of see these applications and what can you actually do. Especially with the networks that are emerging, and that's why we have Christian Kloch as the last speaker today to tell us a little bit about what is the current status of 5G and what does it mean with guaranteed services and how can we collaborate. Christian is from the 5G Innovation Hub, TDC, and Ericsson in collaboration. And what we have agreed is that out of the use cases that we've discussed here, we will try to find one or two that we can realize in practice based on IoT technology. So we very much look forward to that. But Christian, let's hear a bit about your experience with 5G and what's happening today.
Yeah, my slides are coming in a few seconds. I think you can see them now. Just tell you a little bit more about the background. I mean, I've been with TDCnet for about 8 years or so, and prior to joining our 5G Innovation Hub, I've actually been the chief architect of a 5G network, of a mobile network on the radio part. So it means that wherever you go, whenever you use your smartphone, if you have good coverage, then just thank me, and if you have bad coverage, then blame me, so to say. But after we made the agreement with Ericsson, where we also decided to make this strategic collaboration with a 5G Innovation Hub, I'm now looking to what can 5G actually be used for, because 5G is not only just 5G, and I'll come back to that for a moment, but we have to find out how do we actually monetize the different technical capabilities, because without monetization, we go nowhere, so to say. I also have to say, I mean, in the previous presentation, you heard a lot about this short latency, but our experience so far is actually more about controllable latency. That's what we need. So we know how much delayed the remote end will be compared to when we do the controlling. And I think that's a really key point here. And I'll come back to use case and we'll talk more about it later. But basically, when we talk about the mobile network, it's actually a network that evolved quite a lot. I mean, in the beginning, we talked only about voice communication, that I call you, you call me. But today it's used for many more applications, from I mean, smart items on your cell, for different apps on your iPhone or your smartphone. Sorry, I have an iPhone, so that's the reason I have an iPhone. But and it also used within smart home, agriculture, etc. So actually, the cellular network as a platform is used for many different applications, and we see a lot of successful use cases today. So even though we have the dream of that what 5G will be in 2030 and also start looking to 60, we should not forget that actually 5G can do a lot already now with the current setup. So moving on, what is then the difference between our 4G technology and the 5G technology? The 4G is actually the one, the circle in the small circle in this spider web, and the 5G capabilities are put here in the outer circle, bigger circle here, and that's actually the 5G capabilities in 2013. As you can see, I mean, we see a lot of improvements in the cellular technology from 2020 to 2030. But again, think about what you need for your specific application, because you probably don't need the capabilities coming in 2030. You can actually benefit a lot from the fact that you have a pretty good cellular network already today, which actually can be used for many different things. I mean, personally, I always use my smartphone as a modem instead of going to Wi-Fi. Just an example. I always expect that I can be connected to the internet, and I can do a lot of control from my smartphone at other places and so on. But as you can see, yes, we increase the beat rate. Yes, we increase the user experience data rate. And again, it's about, when we talk about this increase in user experience data rate, actually about how much do you actually need to get a sufficient or good quality experience on your device or with this in the application that you're looking into. One thing I want to pinpoint here is actually the improved energy efficiency, because now we talk about sustainability and we say that we need to save the planet. And I only want to say that the more we move on 5G, the more efficient we could transmit our data from A to B, because the technology, the standard actually does it more efficient than what we have seen in the previous technologies. I mean, 2D, 3D and 4G, and you can see there's a huge jump from 4G to 5G. Due to respect of time, I mean, I just want to skip the ones on the right-hand side, but it was more to illustrate what is coming, the release 16 that is currently being rolled out, and release 17. And just for your information, these releases refer to the 3GPP releases, which is the global standardization organization for cellular technology. So of course, we as a local operator, I mean, we are based in Denmark, we are covering Denmark, we have the best mobile network in the world, but still we only covering Denmark. So in case you want to use your application in Germany, it's not our network, it's another network. But I think it's important to say that the cellular technology is actually a global technology, and that means that I mean there's been a lot of focus on this globalization. So it means when you take your smartphone, go to Japan, go to US, you can still use the same smartphone, and that's also one of the drivers why we believe cellular is so important, because you can actually develop something in Denmark that works, Of course, you will come to a country that may not be in the same release as yourself, but there will be a high probability, and therefore your solution will also work when you are selling it to a different country, assuming that they have coverage in that area, of course, because without any radio coverage, you don't get any service. That's a physical law, so to say. But technology-wise, it works globally, which I think is really important. Some of the cases we have been working on at the moment is actually the first one I want to highlight, is actually the one on the right-hand side, where we had a robot for Boston Dynamics. The task was, can we remotely control this robot so it can do inspection along the fence of Odense Airport? And when I say remotely control, I'm not thinking about the way Boston Dynamics plan to do it. I mean, they plan to have a pilot standing next to it and really control it via Wi-Fi. Now here I'm talking about that we are standing in the control tower that you see here in the bottom right picture, and then really via our 5G network control it so it moves along the fence and do inspection of the fence. And this is something that is necessary for the airports to do because it's a legal thing that they need to obey. And if they didn't have the robot, they need to have a person sitting in a car driving along the fence and do exactly the same work. But you can do this by controlling a robot remotely via 5G. And of course, now we do it via a controller, but you could also do it via, you could do it more automatically by adding waypoints and then let the robot move along the fence. The key thing here is that this is not about short latency. This is not about 10 milliseconds that we heard about before. This is about avoiding any packages coming more than 300 milliseconds. Which is a completely different use case. And actually with the 5G network that we have here in Denmark, we often measure 30 milliseconds of delay. You can see we have a high buffer to the 300 milliseconds that actually necessary. But again, it's okay, with the 5G of today, you can get controllable latency, which is an important thing here. And you can actually move persons away from doing the task, but actually doing the machine to do the task instead. Another thing we're engaging is the drone. We are working in Innovation Fund project where we look into how can we use our 5G network for controlling drones beyond visual line of sight. So again, we move away the pilot. We don't need the pilot to look at the drone, but we can actually, again, control the drone from a remote location and then let the drone do its task. And thereby, again, Anders, you talked about the safety thing in the beginning. And I mean, we know that today, if you're going to inspect the K, you need an expert to inspect the K. You need a person in the boat who can control the boat. And you probably also need another person who can stand on the ground. So in case something happens to that boat. But now you can actually let the drone do exactly the same work. And of course, it's unfortunate if the drone crashes, but you don't lose a person's life. You can actually say this is just the loss of a drone. So as you can see here in this case where you inspect the K, which is a pretty normal, not high, I won't say it's a high scale task, but you still need 3 people and a boat. And suddenly we do everything just by using a drone instead. And of course, these things, they are possible and will be more and more possible as the technology evolves, because coming back to where we started, 5G is something developing. I mean, I started to speak about 5G back in 2016. We got 5G in 2020, and the technology will keep on evolving until 2030 and then beyond, because we have 6G. But as we have seen in the previous, whenever we introduce 6G or a new generation of cellular, the old one will also keep on evolving, so to say. But what can we then do from a network perspective? Yes, we can do the slicing that was mentioned before, that we can do slicing in the different parts of the network. We can actually do slicing from, for example, enhanced mobile broadband. Is that the service you want to do? We can also do ultra reliable, low latency communication, massive machine type communication, and public safety. Just to show you some of the slices, so to say, that we could actually activate, and every slice has different capabilities, and it could be different amount of resources in the radio, but it could also be different logical locations of the nodes behind, so to say, because in a cellular network you have more than 20 different nodes, and not all nodes are needed for all services, so to say. So actually, that we have a lot of puzzle pieces, so to say, that we can play around with to ensure that we actually fulfill the requirement of your service. And yeah, and I mean, of course, I would be happy to discuss 5G more details. And so if you have any questions, just reach out to me and we can talk about it. But in respect of time, I just want to show the slide and then go to the final one. This is just one thing I feel is important. And this is, maybe this is politically incorrect, but actually from China, it's actually a slide from Huawei. But I still think it's very important here, because if we just don't do any, I mean, if you're not able to show the business value of our 5G network or our technology, it's hard to explore, I mean, to access all these new capabilities that we see, all this promising thing coming with 5G. But if we do it right and we show that as business value, it has a value for you, we can actually ensure that we bring life, as you say in Chinese. And I think it's also good for us to say, okay, by all these new capabilities we see in the 5G standardization, they become necessary because there's a market for these new capabilities. So that's where I want to stop now, also in respect of time.
And that was a brilliant point, Christian. Thank you very much. And I think that this is also the true reason for why we organized this webinar, is basically to take some of these IoT solutions that we see already creating value within Danish and international markets, and then see that if we start to utilize some of the capabilities that are found within 5G and some of the services that you can now guarantee, at least in Denmark, and then it will, as you say, evolve over time to also be through or across international borders, then we will start to realize some of this potential of changing from the Internet of Things to Internet of Skills.
And I think we have actually, just to add, Anders, I think we have a unique situation here in Denmark because we are so technology front runners, so to say. So I think Denmark is actually a pretty good place to be in right now for doing this test and doing these demonstrations.
Exactly. And also that we are a rather small country where we trust each other, we figure things out. So that's part of the Nordic IoT Center as well. We have this good collaboration agreement to have more organizations to collaborate. So the plan for following up on this webinar and Christian's presentation, Mischa, your introduction to Internet of Skills, is that if any of you want to attend or join in a collaboration project where we demonstrate a practical use case doing this transition from IoT to iOS, feel free to reach out to us, or we will reach out to you based on the slides and the ideas that were generated in the workshop. And then we will, of course, get back to you all with the results of this solution. So what we're able to demonstrate. So we very much look forward to that. So thank you all for joining this late afternoon. I'm sorry that we're running 6 minutes late, but it has been a pleasure to share this discussion with you. Ole, you are raising a hand, and I think maybe you have a question for Christian.
That's right. Hi, Christian. I'm working in the wind industry. If I go here in Denmark, we have been playing a little with remote solutions. With 4G, the connection sometimes fails. What's your prediction with 5G? I'm talking about standing in a 400 feet wind turbine tower made of steel with a thickness of 25 millimeters, maybe going offshore, maybe standing in the Mojave Desert in California, whatever. What's your prediction about the signal connection in such an occasion with 5G?
I think it's a really good question, and it really depends on what are your operator you're subscribing to. I mean, is it us? Is it somebody else? Who is it? And definitely, I mean, the coverage is as it is, and of course it can always be improved locally. But looking to the difference between 4G and 5G, that's probably limited improvement, so to say. The good thing, however, about 5G is that you have IoT solution with very low very low bandwidth or bitrate that actually can where actually much better coverage than what you have on your smartphone. But for you, in your case, where you're going into a metal tower, you actually make it even more challenging for us because you somehow need to have an antenna outside your vessel tower in order to be able to receive a signal. And if you go offshore, then I know that some operators, including ourselves, has tried to make coverage at the water because we have to support the ships sailing around, especially the fishing boat. But again, we do not reach infinitely, so to say. So if you have an offshore windmill farm, it might be out of reach our coverage area. But that's something we need to test. And I know that there are solutions where we actually look into, can we establish a 5G base station in an offshore windmill farm and then use a fiber connection from the windmill farm into the shore and thereby be connected to the internet. But it's something very local, so to say, and as soon as you move away from Denmark, I mean, we are really depending on the local operator.
But is it not also sort of the point in the part of the 5G guaranteed services that there's also some constraints? So you have a closer dialogue with the client, the user of the guaranteed service, where, well, we can interact about this area on this configuration, and within these geographic boundaries, conditions, etc., then we can actually guarantee this service.
I think you have a good point here, because I mean, normally we offering a best effort, so to say. I mean, when you're buying a smartphone using in our network, it's a best effort service. So you get the typical subscription with a certain amount of gigabyte and so on and so on. But suddenly, when it comes to this quality of service and service level agreements, I think it's another setup, and we have not gone that far yet. So I cannot give you the right answer, but I think it's about that. If I promise something, you also expect it. And if you don't get it, then you'll probably be angry at me. So that would be maybe a much closer dialogue here, and to see where do I deliver what I promise.
And the beautiful thing about this is that basically this will wrap up our webinar talking about collaboration and a dialogue between different technical experts to make agreements to make this technology work for all of us, which is all in the spirit of the Nordic IoT Center. So I'm really happy that we can end on that note. Thank you very much, everyone, for attending, and have a very nice afternoon.
Thank you.